Okay, so we've talked a little bit about proofs now. You've done some algebraic proofs. Now let's get into more of some geometric proofs. So remember, a proof is where you're given some information and you're proving some other statement using the information that's given to you. So our I can statement for this section 6.1d is I can complete geometric proofs using properties about angles. So we've learned a ton of different angle relationships and properties about those relationships. So now we're going to use those to prove other things about angles. Okay? So the first one we're going to look at, we are given this picture. We have this giant angle ABC that is split into three different angles, angle 1, 2, and 3. And the information that is given to us is that the measure of angle 1 is equal to the measure of angle 3. That means that these two angles are the same size. Okay? So the information given to us is that the measure of this angle is equal to the measure of this angle. Okay? It wants us to prove that the measure of angle EBA is equal to the measure of angle CBD. Okay? So the statements have been provided for us. We're just going to fill in the reasons and figure out how did we get from one statement to the next, to the next, to the final product. Okay, so the very first statement that they gave us is that the measure of angle 1 is equal to the measure of angle 3. Where did that statement come from? Well, that was the statement that was given to us originally, right? So if that's the information that they gave us to start with, then our reason is just that this is given. Okay, so now I'm going to take that statement and do something with it. Okay, so statement 2 goes to say the measure of angle EBA is equal to the measure of angle 2 plus the measure of angle 3. Okay, I'm going to redraw our original picture really quickly. Onto the side here we have, I always mess this up, we have a big angle like this. We have angle A, B, C. And then this angle is split into 3 angles on the inside. Here's angle 1, angle 2, angle 3, and angles 1 and 3 are the same, which is what those little arcs mean. Okay. We have some other letters here, E and D. So I've redrawn the original picture because I colored on my original picture. Okay. So statement 2 says the measure of angle EBA. I'm going to highlight that angle real quick. We have E to B to A. I know that that's a little bit, there we go. So that's EBA, highlighted in green. My highlighter seems to be very thick. Let's change that. Okay. So my statement says that this angle that I've just highlighted in green is equal to the measure of angle 2 plus the measure of angle 3. Well, we can see that in this picture, right? We have angle 2 is right here, and angle 3 is right here. Those two angles are what make up that green highlighted angle. But how do I know that that's true? Well, this is a postulate that we learned back in 6.1a. And if you don't remember what it was called, it's called the angle addition postulate. Remember, a postulate is like a fact. It's something that we know to be true. Okay? The angle addition postulate pretty much just said that I can add 2 small angles together to get a bigger angle. And that also works backwards. I can take a bigger angle and split it into 2 smaller angles that are added together, which is exactly what they did here. Okay? So that's the reason for statement number 2. Let's move on to statement number 3. Statement number 3 says that the measure of angle EBA is now equal to the measure of angle 2 plus the measure of angle 1. So what's the big difference between statement number 2 and statement number 3? Well, in statement number 2, we're adding the measure of angle 3, and in statement number 3, we're adding the measure of angle 1. So why am I able to switch those two things? I'm going to go back to the information they gave me to start with. At the very beginning, they told me the measure of angle 1 is equal to the measure of angle 3. Well, if they're the same size, I can replace them with one another, right? That's all they did for this statement. They switched out angle 3 and angle 1 because they are the same size. Okay? Whenever we replace something, we call that substitution. Okay? Normally in my class, you've seen me, when I substitute something, I always put it in parentheses. That's all they've done. They just didn't use parentheses. Okay? But they replaced angle 3 with angle 1 because they're the exact same thing. Okay? Now let's move on to statement number 4. So statement number 4 says now that the measure of angle 2 plus the measure of angle 1 is equal to the measure of angle CBD. I'm going to draw my original picture again. Okay, so we have our bigger angle ABC. That is split into three sections, with E and D. Okay, so angle 2 is the middle angle. Angle 1 is the left angle, and angle 3 is the right angle. So this statement says the measure of angle 2, so that's this one in the middle, plus the measure of angle 1, right here, is equal to the measure of angle CBD. I'm going to highlight CBD. Here we have C to B to D. Okay, wow, that highlighter looks a lot better than my last one. I am going to erase what I did there. Oh no, and fix that. Sorry guys, that just looked way better since I changed it. Okay, so back to statement 4. The measure of angle 2 plus the measure of angle 1 equals the measure of angle CBD. That's a lot like statement number 2, right? Where we highlighted our two angles that make up the bigger angle. Okay, the same reason is why we're able to say this as well, the angle addition postulate. Which, if you've already forgotten, again means that I can take the measure of two angles and combine them to equal a bigger angle. That's all they've done here. Okay. Now we're to our last statement. Now it says that the measure of angle EBA equals the measure of CBD. Okay. So how did they jump to this statement, I mean? What's the reason we're able to jump all the way to the final answer? If I look at the two statements before, I have the measure of angle EBA equals the measure of angle 2 plus the measure of angle 1. Okay, so I have the measure of angle 2 plus the measure of angle 1. I'm going to put a box around that. Because in statement 4, it then says the measure of angle 2 plus the measure of angle 1 equals the measure of angle CBD. So again, I'm seeing the measure of angle 2 plus the measure of angle 1. Okay. These two things are equal to each other, right? They're the exact same statement. The measure of angle 2 plus the measure of angle 1. Okay. If I have two things that are different but equal the same thing, that means that those two things to begin with have to be equal to each other. So since EBA is equal to this statement and CBD is also equal to this statement, that means that EBA and CBD have to be equal to each other. Okay, and that property you learned a really long time ago, the name of it. You may have forgotten that this was even one of the properties you knew. Okay, but it's called the transitive property. So the transitive property says, I'll break it down right here, okay, that if A equals B and B equals C, then A also equals C. A and C are both equal to B, so they must be equal to each other. Okay, so that's pretty much what the transitive property states. And that's our final reason. We finished the proof for this. We started with the measure of angle 1 equals the measure of angle 3, and we ended with the measure of angle EBA equals the measure of angle CBD. All right, moving along. Proof number 2. We want to prove the vertical angles theorem. So the vertical angles theorem pretty much is just saying that those opposite angles that we call vertical angles are actually the same size. Okay, so we're given that angle 1 and 3 are vertical angles, right? So angle 1 and 3 are vertical. We know those are vertical because we know what vertical angles are, but because they're vertical, we're now going to prove that they're also the exact same size. Okay, so this is something we talked about in 6.1b. So our statements are given, our reasons are what we need to fill in. We have a little hint on reason number 3 here, but we're going to fill in the reasons. So the very first statement they gave us, angle 1 and angle 3 are vertical angles. That is the given information. That's what they told us up above, right? This here is the same as this here. Just like in our last proof, this information was the same as that given information. Okay, so now down to statement 2. Statement 2 says angle 1 and angle 2 are supplementary, and angles 2 and angles 3 are supplementary. Okay, let's first look at angles 1 and angle 2. Let's see if I can switch colors here. Okay, so here's angle 1 again, and here's angle 2. Okay, those two angles, we have a couple names for the angles that look like that. One is adjacent, they are right next to each other. Because they're right next to each other and they form a straight line, okay, we know that they combine to equal 180 degrees. That's what supplementary means, right? Angles 1 and 2 are supplementary. But the reason I know that they equal 180 degrees is because they form a straight line. When angles, so I'm going to write to the side here, angles 1 and angle 2, they are adjacent and they form a straight line. Okay, what do we call angles that are adjacent and form a straight line? We call them a linear pair. Okay, so angles 1 and 2 are a linear pair, but also angles 2 and 3 are a linear pair, right? They are adjacent to each other and together they form a straight line. So my reasoning here, let's get the right color. My reason for statement number 2, how do I know that those two things are supplementary? Because they are linear pairs. You could also put as your reasoning here, because angles 1 and 2, or I mean, not angles 1 and 2, you could put because the angles are adjacent and form a straight line. I know that they're supplementary. Okay, but the shorter name is that they are linear pairs. I think I'm in the wrong color. There we go. So now to statement 3, we have angle 1 plus angle 2 equals 180. Angle 2 and angle 3 combined also equals 180. Well, what do we know about angles 1 and 2? That's from statement number 2, right? We know that they're supplementary. And supplementary means they add up to 180. So this is why that hint is here. The definition of that word that we need to fill in is supplementary. The definition of supplementary means that these two things are going to add up to equal 180. So let's see. Because it says supplementary here, I know that I can add to equal 180. That just is the definition of supplementary. That's why I'm able to do that. Okay. Statement number 4 now. The measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. Well, let's think back to our proof up above, the one before this. Okay. Remember our very last step, we said because those two things are equal to the same thing, they must be equal to each other. Well, the measure of angle 1 plus the measure of angle 2 equals 180, and the measure of angle 2 plus the measure of angle 3 equals 180. That's the reason statement number 3 from up above. So since they both equal 180, they must equal each other. And the name of the property that tells us that is the transitive property. Okay. So now to statement number 5. The measure of angle 1 is equal to the measure of angle 3. Well, the biggest difference between statement number 4 and statement number 5, I'm going to highlight it in red, is we no longer have the measure of angle 2, right? That's getting deleted from our statement pretty much. How are we able to do that? Well, we can subtract the measure of angle 2 from both sides. If I subtract the measure of angle 2, it's going to go away, and all I'm left with is the measure of angle 1 equals the measure of angle 3. That's just the subtraction. I don't teach English for a reason, because I suck at spelling. Subtraction property. We use that property all the time. Okay. And finally, statement 6. Angle 1 is congruent to angle 3. So the biggest difference between statement 5 and statement 6 is we went from equals to congruent. Okay? The reason we're able to do that is because the definition of congruent means equal. So we can switch those symbols out because the definition of congruence says so. So I would write as my reason the definition of congruent. Okay. We've proved 2 geometric proofs. Let's keep going. We have 2 more. Number 3. We are given that angle 1 is congruent to angle 3. Okay, in that picture, here's angle 1, congruent to angle 3 over here. We want to prove that angle 6 is congruent to angle 4. Okay, so on this one, they give us almost all the statements, and we have to fill in the reasons except for number 3. We have to give the statement for the reason that they gave us. Okay, so the first statement, angle 1 is congruent to angle 3. Whenever you do a proof, it's safe to say you're always going to start with the given information. Okay, see this given angle 1 is congruent to angle 3 is the same. Statement number 2, angle 3 is congruent to angle 6. I'm going to go to my picture to help me see that. Okay, so angle 3 is right here, and angle 6 is over here. So how do I know that those are congruent to each other? Well, what relationship do those 2 angles have? Those 2 angles are vertical angles. That's how I know that they are congruent. Because they are vertical angles, I can state that they are congruent. That's statement number 3, the reason. Okay, so now this is the one where it's backwards. We have to come up with a statement that matches this reason. The reason says transitive property. So for some statement, I'm using the transitive property between statement number 1 and statement number 2 to get there. Okay. Well, statement number 1 says angle 1 is congruent to angle 3. I'm going to write that off to the side. Angle congruent to angle 3. Statement number 2 says angle 3 is congruent to angle 6. Well, if you notice, the thing that they both have in common here is angle 3. They are both congruent to angle 3, right? Well, if two things are equal to the same thing, they must be equal to each other. So really what I'm doing here is now I'm taking out that 3 and sandwiching it together, so it now just says angle 1 is congruent to angle 6. Okay. That's because of the transitive property. Because the transitive property is what says if two things are equal to the same thing, they are equal to each other. Okay. So now let's look at statement number 4. Now it says angle 1 is congruent to angle 4. Let me get a different color here. So here's angle 1, here's angle 4. How do I know that those two things are congruent to each other? Because those are vertical angles as well, right? And then statement number 5, angle 6 is congruent to angle 4. Okay, so I know I am kind of taking statement 3 and statement 4 to get statement 5. So statement 3 says that angle 1 is congruent to angle 6. Statement 4 says angle 1 is congruent to angle 4. The thing that they have in common here is angle 1, right? They are both congruent to angle 1. So what property now is going to allow me to get rid of angle 1 and just keep angle 6 is congruent to angle 4? Well, that's the same property we used on number 3, right? The transitive property. The transitive property is what states that if they equal the same thing, they equal each other. So that's how I'm able to get to statement number 5, which is what it asked me to prove. Okay, let me get a different color here. Maybe. There we go. So angle 6 is congruent to angle 4. That is what it asked me to prove in the beginning. And back in our other proofs, angle 1 is congruent to angle 3. That's what it asked me to prove. And measure of angle EBA is equal to the measure of angle CBD. That's what it asked me to prove. So we're always ending where it asked us to prove. Okay. Last geometric proof. We are given that angle W and angle V are congruent and supplementary. Okay. It wants us to prove that angle W and angle V are both right angles. Okay. So they've actually filled in a little bit for us. We just have to fill in the rest of the reasons. Okay. So first things first, the first statement, angle W and angle V are congruent. That is part of the information that was given to us. Okay. That's not all of it, so I'm only highlighting part right now. The other part might come in later. But that piece of information was given to us. So now let's go to statement 2. The measure of angle W is equal to the measure of angle V. So that really is saying the same thing again, right? If they're congruent, then the measures must be equal. Okay? That's just stating the same thing again using a different method. So we're just changing how that looks. We're not changing what that means at all. Okay? And the reason we're able to say that those measures are equal to each other is because of the definition of congruence. Okay. Statement 1 says that they are congruent, which means by definition that the measures are equal to each other. That's why we're able to go from statement 1 to statement 2. Okay. So from statement 2, now we're jumping to statement 3. Angle W and angle V are supplementary. Okay. That is the other piece of our given information, right? Because in my given information it says that they are congruent and supplementary. So the reason here is that that information is given to me. Okay. So now from statement 3 to statement 4, I'm saying that the measure of angle W plus the measure of angle V, is 180. Well, we know that that's true because we know what supplementary means. So the reason why I'm able to go from step 3 to step 4 is because of the definition of supplementary. That's something that we do a lot, we just don't ever really say why we're able to do that. When I ask you what does supplementary mean, you always tell me it means that they equal 180. So I'm able to write that down because that's the definition of supplementary. Okay. So now step 5 says the measure of angle W plus the measure of angle W equals 180. Okay. Well, the difference between statement 4 and statement 5, we have the measure of angle V versus the measure of angle W. So why am I able to switch those two things out? Well, let's go back to statement 2, right? Statement 2 says that those things are equal to each other. So I can replace them with one another. And whenever I replace something, I call it substitution. And in my class, normally, I put parentheses around it. But that's just substitution. I'm substituting one thing for another because they are the same. Okay. So now to step 6, I'm going from the measure of angle W plus the measure of angle W equals 180 to 2 times the measure of angle W equals 180. Okay. That's just simplifying. That's combining like terms. We're just simplifying to get to that step. We're taking the 2 different measure of angle W's, combining them to be 2 measure of angle W. That's like saying x plus x equals 180. So 2x equals 180. That's all we did there. Okay. So now to step 7, it says the measure of angle W equals 90. Well, if I'm continuing on with my x example over here, if I wanted to get x by itself, I would divide both sides by 2. So x would be 90. But instead of x, we were using the measure of angle W. So how did I get x by itself? How was I getting the measure of angle W by itself? I divided. So that's the division property. And then finally, step 8 says, well, I guess it's not finally, the next step, step 8 says the measure of angle V also equals 90. That kind of goes back to step number 2, right? It says the measure of angle W and V are the same. The only difference between 7 and 8 is I'm switching W and V. And I'm able to do that because they are equal. That's also just substitution. Because they're the same, I can replace one of them with the other. Now finally, our very last statement. Angle W and angle V are right angles. Well, 7 and 8 both say that they're equal to 90 degrees, right? Well, we know that right angles equal 90 degrees, but we know that because we know the definition. So how can I jump from they're equal to 90 degrees to saying they are right angles? By using the definition of right angles. I know right angles are 90 degrees. That's why I'm able to say that those 2 angles are right angles, because of the definition of right angles. Okay. That's it for our geometric proofs for this section. Okay. Proofs are tough, so if you're struggling, don't be upset. Just make sure you're asking your teacher for any help that you might need, okay? Because proofs are tough, but they are really important for math. It's a great thing to be able to start with something and start with some piece of information and say something else is true because of it. So in this last proof, we proved that angle W and angle V are right angles. Okay. We'll keep doing some proofs, get really good at coming up with these reasons that go with our statements in our next section.